Hello again, welcome to another lesson in geometry. Today we are covering section 4.2, triangle congruence. So trying to prove two triangles are this congruent to each other by either using side, 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 or side, angle, side, which are shortened to SSS and SAS. Okay, so we have some vocabulary builder first here. So use a diagram at the right, find each. So the included angle between AB and CA. So AB is this side of the triangle, and CA is that side, and the included angle is the angle that's in between, included in between. So this is going to be angle A. All right. So the included side between angle A and angle C. So angle A is here, angle C is here, and the included side is the one that connects the two angles together. So angle or side AC. So the included angle between BC and CA, so let's do it long ways again. So BC and CA, the included angle is going to be angle C. So the included side between angle B and angle C is going to be side BC. And the included angle between BC and AB will be angle B. And the included side between angle B and angle A is side AB. Okay. All right. Vocabulary builder. Postulate. So a postulate is a statement that is accepted as true without being proven true. So remember, we have no way of proving these things, but we need them to do other stuff. So one postulate, for instance, that we learned back in chapter 1 was between any two lines, there's exactly, or between any 2 points, there's exactly one line. We were unable to prove it, but we all know that that's true. So we assume it's true, then we can build it and use it as a reason and a proof or a statement. Okay. All right. So number 2, underline the correct word to complete the sentence. You can use properties, postulates, and previous proven theorems as reasons in the proof. Okay. So statements is trying to get new stuff over on the left side, and the reasons are the reasons behind it. Okay. So those are on the right side of our 2-column proofs. All right. Multiple choice. What is a postulate? A convincing argument using deductive reasoning? No. A conjecture or statement that you can prove true? No, we cannot prove a postulate true. A statement accepted as true without being proven true. So it's C. Okay. All right. So we can't prove a postulate, but we just all assume it's true, and then we build from there. So on the second page, we have a postulate here, postulate 4.1, the side, side, side postulate. Okay. So this postulate will help us prove two triangles are congruent without having to prove every single corresponding part is congruent. So it says that if the sides of the triangles are congruent, then the two triangles are congruent. So in other words, if you pick 3 lengths of sides, there's only one way to put the triangles together. Okay. All right. So use the figures at the right to complete the sentence. So if AB is the same as DE, that's the 2 red ones, and BC is the same as EF, that's the 2 blue sides, and AC is the same as DF, that's the 2 purple sides, then triangle ABC should be congruent to the other triangle by using the side, 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 because this is all 3 pairs of sides being the same. All right, so A was the point that was between the red and the purple, so that means D has to come first here. B was the point that was between the red and the blue, so E has to come first here. And C was the point between the purple and the blue, so F has to come first here. So triangle DEF. All right. Okay, so using side, side, side. So side, 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 we have here BC, that's this one here, is marked congruent to BF. Okay. And we also have CD, this side, is marked congruent to DF. And we would like to prove that the 2 triangles are congruent. So the top triangle, BCD, and the bottom triangle, BDF, are congruent, or BFD. Okay, so you know 2 pairs of sides are already congruent. What else do you need to use the SSS postulate? Well, we have 2 pairs of sides, so we only need a 3rd side congruent. Okay. So the triangles actually share the third side. They share side BD. It's the same in both triangles. So here would be our proof for this. Our first statement would be part of the given. BC is the same as BF. Okay, that was part of our given. And CD is the same as FD. That was part of our given. And that's two of the three sides of the triangles. So the third side's the same in both, so we could say BD is the same as both, and that's our reflexive property of congruence. So we never thought we would use that. BD is the same as BD. Why would we need that? Well, here we go. Now we can say BD is the same in both triangles. All right, so now since I have all three corresponding sides the same in each one, I can make the triangles be congruent. So my first triangle is BCD. That's our top one. B to C to D. All right. So the first point in there, the first corner of my triangle is angle B. So, and that comes between sides 1 and 3. So down here, our triangle should be angle B also. That comes between sides 1 and 3. And then it went to C. That's the one between sides 1 and 2. So ours between 1 and 2 would be F. And then it went to D, and D is the same in both triangles. Okay, so triangle BCD, the top one, in red, is congruent to triangle BFD, the black one in the bottom. And that's by side, 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 because all three sides are the same. All right, we have one more postulate on the bottom, the last one for this section. Postulate SAS. So this is the side angle side. So if you have two sides and the angle in between, the included angle, so that's why it goes side, angle, side. We need the sides and then the angle that's right in between them. Then you can say these triangles are congruent also. Okay? So down here, which two triangles are going to be congruent by SAS? So side, angle, side. Well, only two of them have an angle marked. So angle D and angle T are marked congruent to each other, and they fall between the 1 and the 3 mark. Okay? So DE F should be congruent to however we name this to get the corresponding sides in the same place. All right. So D was the angle that was marked. So our first angle here should be T. Okay. And then it went to E. That came between the down the 3 mark to get to E. So if I go down the 3 mark, I should get to R. And then we had F, which is the last part, so this will be S is our last part. So TRS. All right. And then we're supposed to say which two triangles could we prove congruent by SSS. So the ones we just did, we can't prove congruent by SSS. We don't have all three sides marked the same. This one has 3 sides marked, but this one only has 2 sides marked. So we could prove these two are the same, the first two, by SSS, because they have all corresponding sides marked the same. All right, so A was the beginning of this triangle, and that came between 1 and 2. So over here between 1 and 2 would be F. So F. And then it went B. B came between the 2 and 3 side. So E comes between the 2 and 3 side. And then the last one is D. So FED. All right. Now you got to be careful in naming your triangle, because if you put EFD or DFE, it's not actually congruent. It doesn't match the corresponding sides the same way. All right, let's flip it over and look at page 3. All right, so problem 2, using side, angle, side. What other information do we need to prove that triangle LEB, okay, is congruent to triangle B and NL? So BNL. Okay. All right, so we want to prove the red and the blue one are the same. What's the only things we have in here? All right, so let's take a look. So circle the angles that are marked congruent by the diagram. So one of the angles is right here, and the other angle is right there. So we have angle ELB, that's in the top right triangle, and we have angle NBL, that's in the bottom left triangle. Okay. circle the sides that form the angles that are marked congruent in this diagram. So remember to use side, angle, side. They have to be the two sides that would be right next to that angle. Okay, so the angle has to be included between those two sides. So we would need this one and this one for the top right triangle. So LE and LB. And in the bottom left triangle, we need this one, which we already marked, LB, and we need BN. Okay, so LB and BL are the same. All right, and so we don't need LN or BE. Okay, complete each congruent statement. So LB is the same as BL, or LB, doesn't matter. Okay, and BLE is the same as, let's see, so BLE is going to be the same as NBL. Okay. Prove the correct words to complete each sentence. So proving, underline the correct words to complete each sentence. So proving triangle LEB is congruent to triangle BNL by SAS requires 2 pairs of congruent sides and 1 pair of congruent angles. Now it requires more than that, remember, because the angle has to be the included angle between the two sides. Okay, so this diagram shows congruency of, let's see, how many sides? Only 1. And shows congruent angles, just 1 pair. Okay, so we only have SA so far. So to prove the triangle is congruent by SAS, you still need, let's see, 1 more pair of sides and 0 pairs of angles. We don't need any more angles, we just need another side. And to prove the triangle is congruent, you need to prove, let's see, which pair of sides do we need? So we need this one, LE, and we need this one, BN. Okay, we already got the one in between, we just need the other one. So the top and the bottom of this. All right, problem number 3. Identify congruent triangles here. So would you use SSS or SAS to prove the triangles below are congruent? We have to explain why. So complete each statement with either SSS or SAS. Okay, so use, let's see, if you have 3 pairs of sides, well, that's this one, SSS, that's 3 pairs of sides, side, side, and side. And we use, well, I'm going to guess the other one, if you have 2 pairs of sides and the included angle. So we got to make sure we have that included angle, not just an angle. All right. So the diagram shows congruence of 3 sides. Well, that's true. We have the 1, the 2, the 3, and we have the 1, the 2, and the 3. So I know I could use SSS. Okay. In the triangle on the left, the marked angle and the included angle of the sides with 2 marks and the side with 3 marks. So the left triangle is this one. The included angle is between the side with 2 marks and 3 marks. Well, that's true. And in the triangle on the right, the marked angle is the included angle of the side with 2 marks and 3 marks. That's not true. It's 2 marks and 1 mark. That's why we can't use SAS. We do not have the right included angle. Okay? So would you use SSS or SAS to prove these triangles are congruent? I would use SSS. We have all 3 pairs of sides. SAS would not work. We don't have the right included angle because we don't have the correct included angle. Okay. All right, so that concludes the notes on SSS and SAS, but there's a lesson check down here. So pause the video and then come back after you've completed it and check to see if you understood the lesson check. Okay, so welcome back. So your lesson check was really checking to see if you understood how SAS works and how this A in here must be the included angle between 2 sides. So you have to have two sides like this, and then this angle has to be in between. And on my other triangle, you have to have two sides like this, and the angle still has to be in between. Okay? All right, so your friend thinks that the triangles below are congruent by SAS. Is your friend correct? Explain. So are there two pairs of corresponding sides being congruent? And this is yes. We have the side with mark 1, and we have the side marked 2 and 2. So those two sets of sides are congruent. Is there a pair of congruent angles? This is yes. And this is why it led your friend believe that he could use SAS, or she, because I have an angle and I have two sides. So that's side, angle, side. I got two of each, or two of sides and an angle. So are the congruent angles the included angles between the corresponding congruent sides? And this answer is no. What we really would need is this angle and this angle marked congruent if we wanted to use SAS. So are the two triangles congruent by SAS? And this is no. The angle is not included between the two congruent sets of sides. Okay, so it's not the included angle. All right, lesson check is complete. So check each off words that you understand. So by now you should understand congruent, especially as it relates to triangles, sides, and angles. Okay, and corresponding is really important because we need to get the corresponding parts of the triangles. Okay, so how well do you know SSS and SAS to prove triangles congruent? Hopefully you're up here. But we will spend all of next class working on proofs about SSS and SAS. So you'll be good at it before you leave. Okay? See you in class.